We look up at the night sky, stars twinkle like distant diamonds. The vastness of space seems infinite. But is this perception of space and time real? Or is it just a trick of our minds? We feel the passage of time, the relentless march from past to future. But what if our everyday experience of space and time is an illusion? What if the reality we perceive is just a simplified version of something far more complex and strange? From Einstein's theory of relativity to the mind-bending world of quantum mechanics, our understanding of space and time has been radically transformed. Prepare to have your mind bent as we explore the mind-boggling theories that suggest space and time might be nothing more than a grand illusion. Fasten your seatbelts, it's going to be a wild ride. Before we can delve into the illusory nature of space and time, we must first grapple with a fundamental question. What does it mean for something to exist? We intuitively understand that a chair exists because we can see it, touch it, and sit on it. But what about something like a thought? We can't see or touch a thought, yet it feels real to us. Does that mean a thought exists in the same way a chair does? Philosophers have debated the nature of existence for millennia. Some argue that only physical matter truly exists, while others believe that abstract concepts like ideas and mathematical principles also have a form of existence. In the realm of physics, existence is often defined by the ability to interact. If something can influence or be influenced by other things, it is considered to exist. But what about space and time? They don't seem to interact with things in the same way that, say, two particles do. By questioning the very fabric of our existence, we begin to unravel the deepest mysteries of the cosmos. Our understanding of space and time underwent a seismic shift in the early 20th century, with the arrival of Albert Einstein and his groundbreaking theory of relativity. Before Einstein, space and time were seen as absolute and unchanging, a fixed stage on which the events of the universe unfolded. Einstein shattered this Newtonian worldview. He showed that space and time were not separate and absolute, but rather intertwined into a single entity, space-time. And this space-time was not static. It could be warped and curved by the presence of mass and energy. Imagine a bowling ball placed on a trampoline. The ball causes the trampoline surface to sag, creating a curvature. According to Einstein, massive objects like stars and planets do the same to spacetime. This curvature of spacetime is what we experience as gravity. Einstein's theory revolutionized our understanding of the universe. It explained the anomalous orbit of Mercury, predicted the bending of starlight around massive objects, and provided the framework for our understanding of black holes and the evolution of the universe itself. Einstein's legacy is not just a new theory of gravity but a fundamental shift in how we perceive the very fabric of reality. Just when we thought Einstein had shaken the foundations of reality, quantum mechanics emerged to deliver another jolt to our understanding of space and time. While relativity governs the universe on the grand scale of stars and galaxies, quantum mechanics delves into the bizarre world of atoms and subatomic particles. In the quantum realm, things get very weird. Particles can be in multiple states at once, their properties governed by probabilities rather than certainties. The act of observation seems to influence the very nature of reality. According to quantum mechanics, even seemingly empty space is not truly empty. It teems with virtual particles, popping in and out of existence in a quantum foam of fleeting energy fluctuations. This suggests that space-time itself might not be a smooth, continuous fabric as envisioned by relativity. Instead, it could be a bubbling, frothing entity at the Planck scale, the smallest possible unit of space and time. This tension between relativity and quantum mechanics suggests that our current understanding of space and time is incomplete. It hints at an even deeper level of reality, one where space and time might emerge from something more fundamental, something that lies beyond our current ability to comprehend. Driven by the need to reconcile the seemingly incompatible worlds of relativity and quantum mechanics, physicists have developed a slew of mind-bending theories. Among the most intriguing are loop quantum gravity and the holographic principle, both of which challenge our conventional notions of space and time. Loop quantum gravity proposes that spacetime is not a smooth, continuous entity, but rather a network of interconnected loops, like tiny loops of string woven together into a cosmic fabric. If loop quantum gravity is correct, it means that space and time are quantized, meaning they exist in discrete units rather than as a continuous spectrum. just as mind-boggling as the holographic principle, which suggests that our three-dimensional reality might be an illusion, a projection of information encoded on a distant two-dimensional surface. The holographic principle challenges our understanding of where information is stored in the universe. While still speculative, these theories highlight the ferment in modern physics as researchers grapple with the profound implications of relativity and quantum mechanics. They suggest that our journey into the nature of space and time has only just begun, and that the ultimate nature of reality might be far stranger than we can currently imagine. The idea that our reality might be an illusion, a carefully constructed simulation, has long been a staple of science fiction. But in recent years, this once outlandish concept has gained traction in some scientific and philosophical circles. The simulation hypothesis proposes that what we perceive as reality is actually a sophisticated computer simulation, perhaps run by an advanced alien civilization, or even our own descendants in the distant future. Proponents of this theory point to the rapid advancements in computer technology and the increasing realism of virtual reality simulations as evidence that creating a universe-sized simulation might be possible for a sufficiently advanced civilization. While the simulation hypothesis remains highly speculative, it raises intriguing questions about the nature of reality and our place within it. As we delve deeper into the nature of space and time, we inevitably encounter the enigmatic concept of consciousness. While physics grapples with the external world of matter and energy, consciousness represents the internal subjective world of experience. Some theories propose that consciousness might play a fundamental role in shaping reality. Rather than being a passive observer of a pre-existing universe, consciousness, according to these theories, might actively participate in the creation of reality. If consciousness does play a role in shaping reality, it could explain some of the strange and seemingly paradoxical aspects of quantum mechanics, such as the observer effect. It could also provide a framework for understanding the non-local connections observed in quantum entanglement. Exploring this interplay between consciousness and the cosmos might hold the key to unlocking a deeper understanding of the nature of reality itself. The exploration of space, time, and consciousness leads us to the edge of human understanding, a realm where concrete answers dissolve into a sea of possibilities. The theories we've explored challenge our common-sense view of reality and suggest that the universe is far stranger and more wondrous than we can currently comprehend. This journey of discovery is not just the purview of physicists and philosophers, it's a journey we all undertake as we grapple with the fundamental questions of existence, consciousness, and our place in the cosmos. By questioning our assumptions, embracing uncertainty, and cultivating a sense of wonder, we open ourselves to the possibility of profound insights and a deeper appreciation for the mystery and beauty of the universe we inhabit. The prospect of space and time being illusions might seem like a recipe for existential dread. If our everyday reality is but a shadow play, does anything truly matter? But rather than leading to despair, this realization can be liberating. It frees us from the constraints of a rigid, deterministic worldview, and opens us to the boundless possibilities of a more fluid and interconnected reality. If space and time are not the absolute boundaries we once thought them to be, then the possibilities for what lies beyond our current perception are limitless. The realization that reality is far stranger and more wondrous than we can currently imagine should fill us not with fear, but with a sense of awe and wonder. And in this journey of discovery, we find not despair but a profound sense of connection to the cosmos and to the infinite possibilities that lie ahead.